Welcome back to another episode of Solidity Fridays. Today, we're going over the Seaport protocol. So, this is the new big hyped code base that's been very talked about on crypto Twitter recently. Um, and I'm joined today, of course, by William Schwab and Rory. And we have a very special guest, Dylan. Welcome.
Hey, thanks for having me. It's a pleasure to be here.
Yeah, it's awesome to have you, man. Why don't you tell us like what your role was in this protocol, in this code base?
Sure. Zero Edge and I have been friends for a number of years. We've worked together on a bunch of EVM kind of gas optimization and various kind of deep projects. So he's been working at OpenSea for a little bit. He built this new Seaport protocol with himself and a couple of people on the protocol team at OpenSea. And once they finished kind of an initial version of it, they invited me and a couple of other people to come on and help review the code as well as optimize it to try to bring down the gas costs as much as possible.
That's awesome. Yeah. So I guess the is your would you describe yourself as like your speciality being sorry, Charles Cooper from Viper just joined the stream. Welcome, Charles.
Hello. I don't know if you can hear
Hey,
me.
Charles.
Hey, Charles.
Yeah, audio sounds good.
Great.
Sweet. Yeah, welcome, Charles. I think there was a bit of a mix-up with some of the scheduling, but super happy to have you on. We're just getting started here, sort of introing Dylan and the gas optimization on Seaport. Yeah, why don't we go into some sort of personal intros? Dylan, how did you get into, I guess, like the blockchain space? And then how did you go from like standard sort of blockchain dev to hardcore gas optimizer?
So I got into blockchain generally when I was about 16. I was running some altcoin mining pools back in the glory days that in like 2013, 2014. Wasn't really a developer at the time though. I got into software development a little while after that, and then in like 2019, I started getting more interested in the crypto side of things. Joined this Discord server called Crypto Devs, which is really awesome. And I met Zero Edge there and a bunch of other great people. Started doing kind of basic consulting work and did that for like a year. And then I decided to build a L2 Ethereum chain with mainnet validation of everything. It's a pretty big project, large jump from doing basic consulting projects. And building that, I think, really taught me just about everything I know about the EVM. So, I had to essentially reverse engineer and find a way to like validate every step of the Ethereum execution process within the Ethereum execution process, like being able to validate sidechain blocks on mainnet. So to do that, I had to like learn Huff, which is this assembly language, and build like a VM within the VM, and basically just step through every layer of the EVM. And so after that, I think it became a lot easier to do any kind of gas optimization project or low level work with smart contracts, stuff like that. But I went into that really not knowing any of that.
Awesome. And what advice would you give to someone who's coming in with a bit of Solidity knowledge to get to like a much higher level of gas optimization?
I would say just learn how the EVM works, like at a low level. I think even if you're still going to stick with Solidity or any higher level language, just understanding how it works fundamentally helps a lot. So whenever a new dev is kind of asking me about getting better, the challenge that I always give them is to go implement a square root function in assembly. And it sounds kind of silly and it's not really relevant to anything, but every time I've done that, even like junior devs have been able to do it in a couple of days. And once they're done, I think they have a lot more confidence in their ability to like learn about the EVM and tends to accelerate things. So that's, one thing. But I think generally it just comes down to making projects and to like challenge yourself. So just like pick something that's outside of your level of skill that you are interested in and just go make it. Beyond that, I don't know, reading resources. Like there's this website, evm.codes, that has all of the EVM opcodes and some information about the VM that's useful. Reading the Solidity docs, following Transmissions 11, he's always posting stuff. But yeah, it's hard to give specific advice for a general audience on that.
No, that was great. I really like the idea of implementing a square root function. I think I've never done that in Yule. I want to try do that at some point. I think that's great. But I fully agree with sort of doing it on a project basis as well and trying to build something that you envision, but it's definitely outside of your comfort zone. Awesome, man. Well, why don't you introduce Charles Cooper of Viper?
Sure thing. Charles is a. I didn't ask you exactly how to introduce you, but I would say compiler dev at Viper, most likely. Yeah, welcome. And if you maybe want to just say a couple words about yourself, maybe your work on Viper, that would be awesome.
Yeah.
And full disclosure, getting to make it here after I messed up the time sequence and told you it was an hour later than it actually is.
No, I'm just having breakfast, so it's fine. Let's see. I've been involved with Viper on and off for 2 or 3 years, but I started full time about 9-10 months ago now, and so I've just been really pushing on it, the code base in that time. Before Viper, I've done a few things, but I was mostly involved in high frequency trading. So I find making things go fast to be a lot of fun.
Wow, I could speak with you for like an entire hour about that. I had not known that. Like, I don't want to derail. Like, at some point, we actually want to see Seaport. I actually didn't know you had an HFT background. That's really cool.
What happens when you're old?
You mean that you don't qualify for the Paradigm Fellowship anymore?
No, not without a fake ID.
Yeah, now we have fake IDs to get ourselves younger. Yeah. All right. Awesome. Definitely one of the reasons, like maybe just even to be a bit clear, one of the reasons why I was really interested in having you come on is because Seaport really, like, I haven't looked through the code base yet, but definitely its reputation of being very low level, like dropping into the assembly quite a bit. So having someone who has compiler level knowledge and especially compiler level optimization knowledge, I thought it'd be very interesting just to see the methodology, like how really to use things like Yule to try and squeeze as much gas performance as much as possible while also keeping the safety rails that we're used to from a higher level language, because I mean we all like code smart contracts and call it high level, and like, get basically all benefits and also pack the gas optimizations to that. So yeah, looking forward. I think with that we're probably ready to dive into the code, Ben. What do you say?
Yeah, I'm really keen to get into the code. I guess like before we do that though, let's maybe take let's like explore the high level architecture of Seaport versus other like marketplaces out there and other stuff OpenSea has done. So, Dylan, do you have any thoughts on that? On the differences between Seaport as a marketplace versus everything else out there?
Yeah, well, I think if you look at like OpenSea specifically, you are pretty limited in like what you're able to do with swaps. So you can't make an order to trade NFTs for each other, and you can't make an order for like multiple items. You can't do a collection level offer, right? There's you basically are limited to trading, NFTs for ETH, and I think maybe ERC20s. And with most marketplaces, if they have like an order book, you can place a specific offer for like one NFT for another NFT, or like an NFT for some ERC20s, something like that. Seaport is much more open with what you're able to do. So you can create an order which has what's called an offer and a consideration. The offer is a list of things you're willing to give, and the consideration is a list of items that have to be received along with the recipient. So there's no fee logic embedded in there. You would just include any fees for the order as the consideration. And then each item in the array of either the offer or the consideration can be ETH, ERC20, ERC721, or ERC1155. And then with the 721 and the 1155, you can do a criteria-based order, which is where you can give a Merkle root hash, and then anybody, when they're fulfilling the order, can provide a Merkle proof. So you could do something like, I'll give 1 Ether for like a Bored Ape, but any Bored Ape that exists, and then someone can just do like a Merkle proof. Or, you can do a trait-based order where you just like build a Merkle tree of all of the NFTs that have a trait that you like. And then you can do much more, you can have better like fee processing. So like if you have a collection on OpenSea where the creator gets a small fee, that would go into the consideration on that. And also, this isn't limited to like OpenSea. It's just an open exchange contract. So as long as the offer is received and the consideration is given, anybody can fill the order. So OpenSea is going to have an interface for this. Other people are talking about building their own interfaces, and then the orders between those will be able to be matched together. I'm not sure if that's a great explanation, but that's kind of a high-level overview.
No, that is great. Yeah, there's some very interesting features in there, especially sort of like how open and composable it is.
There's one other pretty cool aspect of this, which is what are called zones. So zones, it's just you specify an address in an order, and that address is used as a validator for the order. So you can have conditional execution of orders. Like the contract, when it's filling the order, will give the order details or any extra data that you provide to the zone. And then the zone will say, like, is this a valid order that can be filled? And I think that's going to be super powerful.
Awesome. All right. So then I guess, Will, if you're ready, should we just get into it?
Yeah.
All right. So
hybrid foundry hard hat repo, which is interesting. I think this may be the first time I've seen this in prod.
Yeah. Sorry, you were cutting out there a little bit, Will, but we get just hard hat and foundry. Are there any, Dylan or Charles, you guys know if there are like any specific benefits of doing a hard hat and Foundry combo? And I guess like what would it be worth trying to fit Viper in there as well in a repo?
Well,
Hey, maybe I'll actually like dive in. I don't think Foundry has Viper support yet, but I could be wrong about it. I think there is someone working on it. So you would need to go hybrid if you wanted, say, fuzzing from Foundry on the Solidity, but wanted Viper in there.
Yeah, I saw Georgios was sort of polling to see how many people were interested in getting Viper included in Foundry. Yeah, it looks like that might be coming soon.
yeah, Foundry is, I believe, being used for fuzzing here, and then we're using hard hat for specific tests. So it's just different testing methodologies, trying to get as much coverage of everything as possible.
That's awesome. And for the test coverage, is it because as far as I know, there's no test coverage tooling in Foundry, but there is in Hard Hat. Is there a way to sort of gauge your test coverage across both of them, or just sort of on the Hard Hat side?
I'm not actually sure what the coverage reports look like with Foundry. There's been more in terms of like covering different cases, like having them executed on the test. But I'm not sure. I'm not actually that familiar with Foundry.
Okay, cool. Yeah, I mean that's definitely something I think Will and I are also just exploring and getting more familiar with this Foundry. All right, then let's dive in. Straight to the contracts, I guess. This is where we start. I see there's this root seaport.sol, which I have open here. Dylan, is this where we should start, or should we explore into lib maybe?
Maybe up your screen size a bit, like especially on the code. Like on the not code ones, I think it's fine. But like on the code windows, you might want to just up the size a bit.
That better?
Yeah.
There we go.
Yeah, awesome.
Yeah, I think you'll see that the Seaport contract doesn't have too much in it.
Yeah. And I see, Transmissions 11 was also, I believe, like quite pivotal in the gas golfing here as well.
Oh yeah.
So that's great to see. So yeah, not a lot going on in this. Oh wow, yeah, it's very short.
So maybe just give a quick look, just because it is so short. That should be like that should be easy enough. Could you go back up to the constructor for a second?
Sure.
All right. So this is mainly so the main instance right here is from a contract called consideration. And we see that a address is getting passed along, which I'm assuming is going to be like an owner type of address. Oh, we have a contract that deploys conduits or proxies that may optionally be used to transfer approved ERC 2721155. So does that contract have like some kind of super privilege? Like is that, or is it kind of like a registry? We know that anything that's deployed by that address is like in the system, so to speak.
Yeah, so there actually is no owner of consideration or the conduit controller.
Excellent. Yeah. Okay, that's great.
And that's actually what the conduit controller is kind of there for. So if you go to like contracts/conduits /conduit controller, what that is it's essentially a way for different marketplaces to have some additional privilege and like safety checks without anyone owning the core contract. So Seaport is not owned by anyone, but if you have like a big marketplace like OpenSea and you have all these users, you want some ability to kind of pull the brakes if something does go wrong, and keep users' funds safe. And then also you want to be able to upgrade without everybody having to reapprove the core contract. So the conduit is just that. It's a conduit for transfers where users approve the conduit for a particular marketplace, and then the conduit executes the transfers for orders. And the conduit itself, the code for it is always the same, but anybody who deploys one becomes the owner of that conduit, and then they're able to decide what are called, they're able to approve and remove what are called channels, which are addresses that are allowed to transfer tokens from users. And so you would approve Seaport as a channel for like OpenSea, and then users can decide whether to directly approve Seaport and trust the contract, or approve the conduit and not have to pay for another approval if it upgrades, and not have to worry about removing their approval if something happens with the contract. Assuming OpenSea reacts in time.
Cool. Cool.
Nice. So from here, I guess we've covered a little bit of this the main Seaport contract, which is just going from.
I do see that you're using assembly to return the name, though, which is interesting. So it sounds like the contract has a name kind of like an ERC20 or ERC721 token. And so you've got name over here, which is an internal, which returns the string of the name. But I see that you're using assembly for it. So if I'm reading it right, I hope I am. Basically, you're storing whatever's in memory from 0 to 20, which I would assume is empty right now, though I don't see the function which is calling this. So, I mean,
it's storing 32 at position 0. So that is the offset for the string.
Okay. All right. And then I assume 0x0753, etc. is the Unicode for Seaport.
It's actually, so it's both the encoded name and the length. So this is storing at position 39, this 8-character string. So then at byte 63, you're going to have 7, which is the length. And then 64 to 71, you're going to have Seaport. And
interesting.
There's not really any particular.
Yeah, this is kind of a neat trick, actually, which is everything in the EVM is like, how do you say this? So like this number 0753 or whatever is like right padded, or sorry, left padded. So like the numbers are all on the right hand side. So in order to get but you actually want 07 and this other thing to happen on like this boundary, right? So you want the first word to be 32, which is what line 40 does. And then you want the second word to read 07. And so in order to get it to be 07, you push this entire integer and then you plop it on like this unaligned area between slots 32 and 64. Did anybody follow that?
Yep.
Cool.
It's easier with a drawing, but
yeah. It doesn't really do, like, there's not much of a reason to use it for assembly because it's only really going to be queried off chain. But the reason that's in here is kind of like as a warning, kind of like, hey, look, there's some complicated stuff going on here. You should pay attention.
Is there actually an optimization that happens from doing this in assembly as opposed to just returning, straight off? I guess the only other option would be, and I guess if you were writing, go for it.
Normally, the way you would generate this code is there would be 3 M stores. One is like M store 0 OX20, M store OX20 OX07, and then M store OX60, the rest of this stuff.
Okay. So you do optimize so you get it into 2 M stores. So you don't have to let 3 words. Or, well, when you're returning, it's not returning in separate. Memory doesn't return as separate words, right? You just return whatever slice of memory you put into return.
Right.
Yeah.
So it's saving that 1 M store then.
Yeah. The reason I said doesn't.
Sorry.
Sorry, I was just saying the reason it doesn't really like matter is because there's no, you don't pay for gas because it's just a view.
View. Yeah.
But it is an optimization. Yeah.
Optimize all the things. Yeah, for sure. Cool. All right.
Got to make that ETH call like a millisecond faster.
Right. And also, it saves a couple bytes of code size. It's not.
That's
Oh.
Yeah, that's true.
nice. Sweet. Should we jump to like some of the juicy functions? So like either a token transfer or the order book matching stuff.
Matching sounds awesome. I'd throw my vote in for matching.
All right. Where would we find that? I guess lib.
It's an order combiner.
Order combiner. Sweet.
That is the internal functions. The consideration.sol contract is like the root that has all the external functions.
Sweet. Okay. Wow. As people were saying in chat, great NAT spec. This is looking. I think Will and I really appreciate comments in the code, especially in smart contracts. So this is awesome to see the NAT spec like this. It's very informative.
Tried to be very careful to explain like everything that was going on since it is such a complicated contract.
Yeah. And the code isn't necessarily easy to read either. So yeah, I think NAT spec becomes very important. Which function in particular should we dive into here?
Let me see. Match advanced orders is one of the order matching functions.
Let me just
Actually, the order matching function.
yeah, there we go. Right. So let's maybe go through the NAT spec just first. So an internal function to match an arbitrary number of full or partial orders, each with an arbitrary number of items for offer and consideration, supplying criteria resolvers containing specific token identifiers and associated proofs, as well as fulfillments, allocating offer components to consideration components. Wow, quite the mouthful. Sweet. Let's dive in. And yeah, I guess let's go from here. So what are we passing in here as parameters, Dylan?
So you have advanced orders. Those contain, all the different order objects, their signatures, and so on. They have criteria resolvers. Those are used where you have an order that specifies that it has criteria. So that's where you're going to use the Merkle proof. So the criteria resolver is going to specify like what item you're referencing there, and then it's going to have the Merkle proof, and then the when the contract's doing the validation of that, it's just going to verify that it's a valid item in the order. And then you have fulfillments. So fulfillments specify an item that's either on the offer side or the consideration side, and then it says the order index and the item index. And so you pass in a bunch of these, and the match function will go and collect all of the items that you've passed, and you can use this to aggregate transfers. So if you have like two different orders that both specify the same recipient for a given token, then when you're passing in the fulfillments, you can just put those together and it'll be aggregated into one function. And so then when it's going through the fulfillments, anytime that it encounters an offer item that's matched to a consideration item, it'll reduce the amount of the consideration that has to be received. And then at the end, it'll like go through and make sure that all of the considerations are zeroed out so that they the order conditions have been met essentially before transferring.
And so I guess just in the definitions, you may have gone through this before, and if so, I apologize for it just kind of flying out my other ear. In terms of the terminology that's used on the platforms, we're seeing orders, we're seeing fulfillments, and we're seeing considerations. Is consideration just a general term for something that's either an order or a fulfillment?
Oh, no. So a consideration is in an order, you have an offer, which is what you're willing to give, and that's an array of different items. And then you have a consideration, which is what must be received. but not necessarily by the offerer. So each consideration is going to specify an item or an item with criteria and a recipient. And so when you're filling an order, all of the considerations have to be met in order for the offer to be given.
So offer is what happens when there's a consideration that matches to an order. Like there's a consideration and it actually like fills criteria for what the person who possesses the assets currently is willing to give them up for.
So you said
Sounds like I missed it. Sorry.
You said the offer is that? Sorry, you're cutting out.
Sorry if my connection's cutting out. So that means that the consideration, it's kind of like the offer that's being made to get assets, and if they meet the criteria of whoever owns the assets, so then they're matched.
So you mean like for the fulfiller, like the person who's executing it?
Okay, that might even be what I was missing. As in, the third party can fulfill. Like, I guess how does fulfillment happen then?
Okay, so
like
there's
somebody, yeah.
There's two ways an order can be executed, right? So there's one where you call a function called like fulfill order, and there's a few variations of that. With fulfill order, you are effectively creating the mirror of whatever the order is that you're fulfilling, right? So you're going to provide all of the considerations, and you're going to receive all of the offers. With order matching, you're providing orders that already exist and specifying like the offers from this order are going to be used to fill the considerations of this order, right? And you can match those however you want. So you could have like one order that wants an NFT plus like ETH and DAI, or is giving an NFT in exchange for ETH and DAI, and another order that's like giving ETH and DAI in exchange for an NFT, and then you can match those together and execute them at the same time. And you can do that with like any number of orders, so long as all of the orders that you provide have their considerations met at the end of it, then the offers can be sent.
Nice. So that just the purpose is just to check and enforce this like atomicness. So within like this atomic fulfillment, there's a bit of like creativity and space to kind of do what you want there.
Yeah, absolutely. I think that's going to be a ripe space for arbitrageurs to make good bots.
I wonder what MEV strategies could come out of this.
Yeah, absolutely. There's a lot of room there.
That's so interesting. Wow. Maybe we should do a follow-up episode at some point. Get on some of the MEV guys. Oh man, that'd be really cool to see what ideas they have.
Good luck getting them to talk and or tell the truth.
You're a PsyOps episode. Okay, sweet. So should we get into one of these internal functions and try and drill down into some assembly? Like, where would we go from here?
Yeah, we can do that.
Maybe this guy.
Let's see which one has some assembly. I don't think the validate one does.
Look at that. The plus I instead of I plus plus. And it's also within an unchecked block. Yeah, so yeah, I just pick up on all the little gas optimizations. Great stuff.
Save all those conditional jumps.
Yeah. Okay, cool. Let's apply fulfillment.
The fulfillment applier function has some pretty cool assembly blocks.
Okay, so fulfillment applier. Cool.
So the fulfillment applier is where you
Okay.
take all of these items that say like what orders to match with each other, and go through and actually aggregate them.
Okay. So I'm in the fulfillment applier lib here.
If you go to apply fulfillment
Okay.
function, so what this does, you give an array of orders and an array of offer components and consideration components, right? And then each let's see, how do I put this? So when you give a fulfillment, it specifies an array of items on the offer side and an array of items on the consideration side. And then it will go and aggregate the total of each side, making sure that all of the items are the same type. And the purpose here is you want to have efficient order matching. So the caller has provided the like indices of all the items that match each other. And then you want to just go and say, if these are all the same token, then reduce the considerations by the amount of the offers, if that makes sense. So the aggregate valid fulfillment offer items function is, it has this array of offer components. Each of those has an order index and an item index. And then it has the original array of all of the orders that were provided. And it returns this execution struct. The reason that is given as an input parameter is just to save a little bit of gas on the memory allocation.
Right. So do you kind of build this object sort of beforehand and then parse it in and then kind of complete it on chain? Is that the idea?
The execution object is what gets built on chain.
Yeah.
It's an input on the internal function. Just has to do with the memory handling.
Oh, I see. Okay, nice.
But then the internal aggregate valid fulfillment offer items and aggregate valid fulfillment consideration items are the ones that are really heavy in assembly.
Which this one or consideration items? I mean, we could go for either here.
Yeah, both of them. They're essentially the same. They just have a couple of different checks.
Okay, cool. Here we are at aggregate valid fulfillment offer items. I'll just go over this net spec again. So internal pure function to aggregate a group of offer items using supplied directives on which component items are candidates for aggregation, skipping items on orders that are not available. And so just to recap, we're passing in an advanced order array, which is the orders to aggregate offer items from. We're passing in a fulfillment component array, which is the offer components, an array of fulfillment components, indicating the order index and item index of each candidate offer item for aggregation. And then, yeah, as you were just saying, the execution object in memory to apply the aggregation to. Very nice. Okay, sweet. So what's going on here? Maybe like I see we're now doing some inline assembly. This is where stuff's going to get deep again.
Yeah, so in this function, we're having to read from this array and then be able to like find pointers to the object, because the advanced orders parameter is an array of structs where each struct then has a nested struct that then has arrays of structs. And so it's a pretty complicated object as far as ABI encoding goes. So this function is having to go through the offer components for each one, grab the order index, and then in the advanced orders array, find the associated pointer for the order at that index, validate that it's not out of range, and then look at the offers array within the advanced order, find the pointer to that, get the struct, and then read the values from it, make sure that they match the first item because all the tokens have to be the same, and then take the sum of all of the amounts. And it's a somewhat complicated way of explaining it.
Yeah, I mean, I'm just going through it. I think it's super helpful that you have sort of comments at each step, because I think it reduces that sort of mental load when you're trying to read sort of this line or whatever, exactly what's going on. This is really great. This would probably be great learning material for people trying to just read a code base and understand Yule.
Yeah, I think so. It's also nice to have these named constants as the pointers. Normally when you see Yule code like this, most of these values will just be like a hex string, and it's kind of difficult to read.
Yeah, that's a good point.
Yeah.
Oh wait, so this is how you write a for loop in Yule. I don't even know if I've seen this before. 4 brackets less than fulfillment. That is really cool. I don't think I've actually seen a for loop inside Yule before. So this is okay. So this is where that iteration you were talking about happens.
Mm-hmm. Yeah, you have to loop over the fulfillments, and then for each fulfillment, figure out where the order is, and then we take the item index. So then that's going to point to an item in the array of offers for the order. And then at each step, we have to validate the index, make sure it's not out of range, which Solidity will do by default. And then we validate that the recipient is the recipient we're expecting, which for offers is the caller, and then validate the item type, validate the token, and the identifier, which is for NFTs. Yeah.
Interesting. It's interesting for me to think about what this would look like in plain old Solidity code. Now, I didn't catch the whole setup for exactly what's happening inside. I think you said this is an array of structs that's located inside a struct. So you would need to, I guess, for loop through the array of structs. You would call up each item out of the struct that you're looking for and perform each validation on it. Yeah, I mean, in terms of the lines of Solidity code written, it doesn't sound too bad. I mean, you're basically just looping through the array, validating different parameters in the struct. Is that right?
Yeah, there's a reference implementation here in the root of the repository. There's a directory called reference, and then you have all the same files and functions. So there's another one that's implemented in Solidity, and it's about the same size. It's just follows.
So basically, I guess here you're really dive into kind of why assembly ends up being more efficient than Solidity here. So I mean, here what you've done is you've set up a set amount to jump the pointer each time you iterate through the loop. You set exactly where to look to see if the struct item is zeroed out. You do the range check, you do the validations, and that's the loop. If I'm not mistaken.
Yeah, exactly. And there's a lot of small things that Solidity will tend to just be a little less efficient with, like, when you're doing the out of range check, doing that in assembly can be a bit cheaper than the Solidity compiler will do. When you're just like directly like reading a value and then writing it to storage, like if you have a type in a struct and you read from it in normal Solidity, a lot of the time it'll like do a mask on it, and do like other data validation steps that aren't really always needed. The memory access is also a lot cheaper, like just knowing where the pointers are going to be. The way that we handle it here is more efficient. Like you said, we have the pointer of where we're at in the head of the array, and then at each step we just increment that by 32 and go to the next one. Right. So
that's interesting. Since Solidity, like in general, like, the Solidity compiler doesn't know the exact structure of all structs, since structs have arbitrary different structures. So as a result, the code that it compiles down to when it has to like kind of iterate through structs, by necessity ends up more general, for less efficient than kind of customizing exactly what needs to happen and how far you need to jump.
Yeah, exactly.
Cool. I remember there was this ancient, Solidity, Solidity lore. I remember way back when some anon once put out. It wasn't a gist, but it was almost like a gist. It was just this like one file of straight opcodes about pulling structs into memory, which he called Solcia Comedy in One Act, as he just kind of like rips through all the opcodes. Yeah. So that was like fairly ancient Solidity. I think that was either in like Solidity 3 or Solidity 4. I don't even remember. It was 4. Yeah. So yeah, comes to mind. So like you're saying, structs are a big area where kind of like you'd be looking for savings by dropping into something, being able to customize exactly how you access, how you iterate through arbitrary data structures.
Yeah, arrays as well. Like if you have an array of dynamic values in Solidity, if you want to loop through each item in the array, then at each in each step you're going to say like value equals array and reference like the index, right? So in Solidity, what that's going to compile down to is it's going to get the offset for the start of the head of the array. So the head is it's going to have pointers to each actual item. So like at the start of the array for each index, you're going to have a 32 byte value with just the pointer in memory of where the actual data is. And so at each step in the array, if you're referencing it by the index, Solidity is going to take the index, multiply it by 32, and then add it to the start of the head of the array. Whereas if you're in assembly and you know that the index is only going to increment by 1 until you finish looping, then you don't need to multiply at each step. You can just add 32. So it's little things like that.
There's another thing that Solidity has to do, which is when you access it like array subscript I, right? It has to insert a bounds check that I is not greater than the actual length of the array.
Yeah.
Which is expensive in a loop.
That is definitely that saves another like 15 gas or so on each step, and potentially more given how Solidity tends to operate.
If I remember, Viper just put out the. I seem to remember with the Viper dynamic arrays, they do that by setting a maximal bound, though, so they always know where the boundary is and don't have to keep on checking. Is that right?
Actually, in Viper, well, there's two ways of iterating over an array. There's the how do you call this? The Solidity way, which is like for I in range something or other, yada yada yada, and then you access the array the same way. And then there's the iterator way, which is like kind of Pythonic, right? So you're like for item in array ... And then that because in Viper you're not allowed to modify an array while you're iterating over it. All the bounds checks are elided, so that's pretty neat.
I feel like a horrible pleb, but I'm actually going to need to ask what elided means. I mean, it
Yeah.
means, I believe, to depart or get out of something, but yeah.
Skipped.
Got it. Super cool.
Sweet. I mean, I think we only have like 5 minutes left. Is there anything else we should just briefly touch on in the code base? Or would you guys like to touch on? I don't know. It's a bit of a contentious point, but I saw there was going to be a rewrite of this in Viper. Any thoughts on that? And does anyone know how far that is?
Yeah, we have a little working group working on that. And I think it's super cool to see all these people coming together to collaborate and implement this in another language. I mean, it's such a complicated contract. I think the people working on Seaport, and then all of the guys that have come in from as Viper developers, I think we're all learning quite a bit. There's been a lot of discussion about the Viper compiler and differences between the sort of benefits of Viper versus Solidity in that group, and it's super cool to see.
It is
And
really
it
cool to see
also
the
helped-
collab. Oh, yeah, go for it. Sorry.
I'm in that group, and it's also helped like drive development of the Viper compiler because we get to see. I get to see what is important. So like we're gonna add enums very soon and stuff like that.
That is really cool. It's really cool to see with Seaport also, because like one thing I thought when I saw that there was like actually a working group getting together for that is for so many platforms, I would think though, I mean, Charles, correct me if I'm wrong about this, that rewriting in Viper would actually be incredibly difficult just because of the amount of inheritance that you would need to kind of wade through from projects that are inheriting from major libraries like OpenSea or Soulmate or whatever. Whereas Seaport, from everything that I've seen, is really entirely self-contained. So it struck me as like a really incredible target to really see, like, trying to write the platform in Viper versus trying to write the platform in Solidity.
Yeah, I think that there's an entire ecosystem in Solidity which is hard to recreate of libraries and such. But also I see like a lot of top level projects, Seaport, Uniswap, Curve, which are not all Solidity projects.
People have tried rewriting Curve and Solidity. as the ecosystem joke goes, Curve's biggest moat is it's incredibly difficult to understand math.
Right. And it seems like they generally kind of self-contained. They don't rely on external libraries as much as other.
I mean, I guess other projects. Yeah, other projects that we've seen in the ecosystem. Yeah. I guess that really is a sign of advanced engineering to some degree. Is like, when you start like not relying on the common libraries, like, I guess my own space, like starting off, you would never roll your own ERC20 token. You would never roll your own ERC721. But like, I guess as time goes by and you understand the underlying building blocks better, and then when you go even a step further in that and start to understand kind of just underlying that, the like how the EVM is dealing with all the all the different components that you're like feeding in through the higher level languages through to like all the way down into opcodes and into the bytecode. Like, yeah, I guess you do get to the point where like it becomes like the wisest choice ends up being just using your own library system, like say Uniswap or other platforms that you mentioned.
Yeah, you start dreaming in EVM opcodes and then
loading dreams into memory before returning. Yeah.
right. Then you don't need libraries.
All right.
Awesome. Well, I guess we're at time here. I think that just about wraps it up. Any closing comments from you, Dylan or Charles?
Just thanks for having me on. It's been cool to talk to you guys about this, and it's awesome to see so many people taking an interest in both the project and the low-level code. I think it's kicked off a lot of cool discussions.
I see there's a library of low-level helpers. I want to go through that on my own at some point. We didn't get around to it here, but like, yeah, like just read through all of that, square roots and pure assembly. Sounds awesome.
Sweet. Awesome. Thanks, guys. Yeah, and thanks for coming on the stream. This has been really great. Really enjoyed it.
Yeah, thanks for having us.
We good, Rory? I'm good. I hope so. Otherwise, people get my random ending comment.
Are we
You're muted, Rory. Yeah, like, are we still streaming?